with number 9, right? So the graduate, that one's pretty. The null and alternative hypothesis is equal or greater than. That was it. Okay, go. Sorry. Trial. You guys can keep going. So yeah. B, what'd you guys get? Type 1 error, type 2?
I got type 1.
Yeah, I put type 1 because, and is it because of how small it is, right? If a type 1 error is extremely small.
I think it's
or low chances or something. Is that the difference?
I think, well, what made me think it was because it said the null hypothesis should be rejected.
Gotcha.
But,
it's all, excuse me, in the wording.
Yeah.
I didn't understand the type 1, type 2 thing. Okay.
So type 1 is if you reject the truth.
Okay.
And type 2 is if you accept the not true.
Gotcha. Okay.
Does that make sense?
Yeah. I'm writing that down. All right.
Yeah.
Thanks. All right. C. What's the probability of committing a type 1 error?
So how do you set that up?
It's just looking at it. It's 0.01, so it's 1%. So if it said like 0.25, it'd be 25%. So it's just converting the decimal to the percentage, correct?
Yeah.
Oh, that's it? Okay.
Yeah. I know. It's one. Don't worry. It took me a while when I was like, oh, okay. You're not alone. Yes, that's fine. Okay, D. Would you want to increase or decrease? Sorry, you guys can keep going.
You want to decrease, right?
Go.
It says increase.
Alpha. Oh, it says increase?
Yeah, I'm not really sure why.
Is it just because in the question it says that the professor feels now that the score has improved? So isn't that what you're aiming for?
Yeah.
If you're making
Yeah.
error, you
I think you're right.
are, okay, so it's when the null hypothesis is false that you fail to reject it. Am I wrong or right? Does that sound normal?
Sorry, what's your question?
So to have a type 2 error, the null hypothesis is false, but you fail to reject it.
Right.
Yeah.
Right. You're accepting that the false is true when it's not.
Yes. Okay, so then levels of significance is your alpha, and you choose that before you do your experiment, and then you measure your p-value to that. So I'm just trying to think in my head, why would it increase the significance?
Well, if we're accepting the false, so if we're accepting that the scores have not improved within the last couple of years, we would need to increase the level of significance. I'm trying to say this out loud so it makes sense.
Yeah, I think that makes sense. Because if you're increasing it.
So the level of significance, that is equal to your z-score, right?
I don't know. I'm not sure.
Let me look at my notes.
Right.
Hold on. I know I wrote this down somewhere.
Level C. I know. I need to go back to my notes. I'm gonna...
I would feel like I would.
All right, my computer. All right, let's move on and then we can come back to that because, yeah, I think we all are questioning that.
Okay.
It's probably something very simple, though. That's what I feel like. I feel like it's just a definition, right?
Your level of significance is your p-value, or is equal to it's the applet, like the probability of your p-value.
The area, like in the.
Yeah.
Or wait, hold on.
Is that it? Well, that would make sense because if you increase it, then it takes you on the outlier
Okay,
area.
So your level of significance is the thing that you put in the z-score spot in the applet to get your p-value. So if the level of significance increases, then the mean or like their grades would have increased too, right?
It'll be further away from the mean, meaning it would be.
But like more positive.
Okay.
Okay.
I think in my head it makes sense.
That sort of makes sense.
All right.
Should I read this? A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the normal average. He randomly selects 15 of his clients who purchased an investment property and obtains the values. Okay. So I said the population, I don't know if this is right, but I thought it would just be all second home buyers, or is it just his clients that are second home buyers?
No, I think it's the second home buyers
in general.
Well,
I think it's just for him.
It says the average of those buying investment property in his area.
Yeah, I think it's just in his area.
Is different than the national average. So he would be including the whole national average in his study, but he's seeing if his area is different.
Yeah.
Okay.
I agree.
So the population would be everybody, and the sample would be his people, right?
Yes.
I think so.
I guess so.
No.
No, it's just the population is his people.
Okay.
Okay. So I wasn't really sure how to explain this, but I said he samples the population by randomly selecting 15 second home buyers in his area that are his clients.
Yeah. I think that question was just like, what are different ways they could randomly select the sample? I'm like, he could have gone in his computer and randomly selected a few. Or I don't know.
Yeah.
Is that what it was asking? Like, come up with different ways? I was like, grab some files and pick out 15 of them. I don't know.
Do you think it was asking what he used, like stratified sampling?
No, I think it was just I think it was simple random. Hold on, did I understand that right?
It says that he randomly selects people. That's all.
That's true.
Yeah. So I just thought it was simple random sampling. I always say SRS or whatever.
Okay.
I don't know.
The research question. How does people in his area, the age of second home buyers, compare to the national average? I would say. All right. Collect the data. Name at least one way the realtor could have randomly selected his sample. I just kind of said cluster sampling. It was just, I don't know if it was just like, oh, what's one possible way? I don't know if that's right though.
I guess he could have done it anyway. Yeah, when you think about it, he could have done simple random, just gathered. He could have clustered. Well, cluster, no, because wouldn't it have specified if there were specific people, like 20-year-olds, 30, 40-year-olds? So I think he would just have to randomly grab it, or maybe, what are the other ones? What's stratified?
Yeah.
Which maybe it is more, sorry. Anyways.
Okay. So on my graph, I said the data is not normal.
Yeah, I put it was left skewed. Was your all's left skewed?
I don't know if mine was left skewed. It was just like, just kind of dipped down in the middle.
Yeah.
Maybe that is left skewed. I'm just not reading.
Well, no, I didn't. I think it's
model or whatever.
That's
right?
what I was gonna say. Maybe it could be by model.
Oh yeah, it kind of does. That kind of does look left skewed, but it is.
Maybe it's both. Maybe I should never be a statistics. Maybe. Yeah. Anyhow, I feel good about that. Yep. Hold on, buddy.
Check the requirements since there are only 15 pieces of data. what will you
need?
check?
So we'll need to check. Well, we just need to check like the ages, right? We need to check the ages of the people and the properties in that area. We're going to need to check for the deviation. We need to check, I don't know. Is that just kind of a, because it's making inferences, meaning we need to infer.
Mm-hmm.
Am I making this up in my mind?
I didn't answer that one. I'm trying to find my freaking.
The answer sheet has like the age, the alpha, the z-score, the p-value, all that stuff is listed for unique inference.
So just all the data, right? We would just need to gather all the data so we could.
And then I think that's where it's you know, having you work through the whole problem and see what your conclusion is basically what we're doing through this next steps.
All right. State the null and alternative hypothesis.
So the null hypothesis is
people buying a second home as an investment property are 47. So the U would equal 47 years old, or they're trying to see if it's different. So it would be U equals with the slash, because they're not trying to find greater or less than, they're just trying to see if 47 is the average age, correct?
Yeah.
I got 47 for the average when I input the data. Well, it was 46.7. So
yeah, so pretty close.
Pretty close. Let's say.
It says we have insufficient evidence to conclude that the mean age of people buying a second home is different in this area than the national average.
Yeah. So I'm not sure what it means if this is one or two-tailed test.
I think it would be two-sided because it's normal distribution. And it's the equals or not equals, and so that's two-sided, and the less than and greater than that's the one-sided.
So one side, okay, yeah, we talked about this earlier, right?
Hypothesis, though, if it's pretty much the same.
What?
Would we have an alternative hypothesis?
Yeah, the alternative is that the alternative is that it is different.
Okay.
Or that it's not different or whatever. So whatever, it's the opposite of what the hypothesis is.
Okay. So would we say it's less than the null?
No, because he's trying to find out if it's different. So it's either not different or it's different. And so this says that we can't determine that it's different. So we're saying that it's not different.
So what would that be? Would that be mu does not equal like 0, for example? I just got that from like the.
I don't know. Sorry.
So the null would be equals 47, and then the it's all about the wording in the problem. If it says it's greater than, then you're going to get the little Pac-Man, greater than. If it says it's different, we're trying to find out if it's just different, then it's the equal sign with the slash down the middle. Does that make sense?
Right.
For the alternative hypothesis.
Okay. That's fine.
That makes sense. Sorry.
Yeah, that makes sense.
My brain shut.
All right.
No. Ace here.
I think part of my question got cut off. I see let as the beginning, and then there's nothing else there.
Let A equals 0.5. So that's our, what's it called? What is my brain?
Oh, your level of significance.
Which I don't know. Okay.
I put a cheat sheet in the message for the group chat.
What's the whole point of A? I was rereading and I was watching the videos, and the A level.
So
It's just the level of significance.
Was that A is something you choose before you conduct your research.
Okay.
So you say, oh, for this test, I want the level of significance to be 0.05.
Okay.
Or like, I want it to be 0.01, or I want it to be 0.1, for example. I think those were the most common ones. And then after that, you calculate your p-value.
Uh-huh.
And if your p-value is lower than your alpha, then you're going to reject the null hypothesis.
Okay.
So I'm not quite sure how we find the p-value yet. I know that it's like the probability that you got your results or something.
All you do to get the p-value, to get the p-value, and this kind of answers the next two questions. You get the z-score. So once you get that z-score, you input it into the probability applet on the bottom. So for this one, the z-score was 0.207. So you put that in, and then you click the middle, and it gives you the area, the probability, which was you click the left and right side because we're trying to. I'm sorry, is that correct? And then it gives you the area. The area is the
p-value.
The p-value. Yeah, so the area on the top of the probability applet, that's your p-value.
Oh, awesome.
Does that make sense?
Mm-hmm.
So you shade the left and the right because we're trying to figure out what.
I'm gonna get captured.
What?
What are we trying to figure out? I think
Is there a guy in our group? Oh, shit.
I don't know.
So sorry, let me ask you this though. When we're finding the z-score, 47 is and then I've got 5 is the standard deviation, n is 15 because we're doing the 15 people. What's the x? Is it just
46.7?
Oh, from our data we got. Is that it?
I would.
Okay, I'm gonna put that with.
X is what you're like trying to compare it to. Like if the mean is this, and then we're trying to find if there's something different, then that would be the X.
So are we doing 46.7, the mean, the information that we got out of the previously?
I would think so, because that's what you've observed.
Yeah. All right, I'm gonna calculate it and see if it matches, because that one I didn't understand. I was like, well, where do I find but okay. You guys can keep going if you want. I just want to.
I'm actually
right.
Got negative 0.23.
It's negative 0.207 is what the answer they gave in the.
Maybe I didn't put enough decimals in my.
I know, I hate this. I need a new calculator is what I'm discovering.
Let me try this. 6.72333.
Bless you.
That was my husband.
Well, bless him too. Okay. Negative 0.27. Oh my gosh. Okay. I've got if I input 46.7, I didn't put 46.73, but I think same thing you got was negative 0.209.
Yeah. I put in like a whole bunch of decimals after that, and it didn't get to 0.27. So
what if it's just 0? I don't know. All right. Maybe I'll shoot her a message and ask that, because I don't know. Because what's X? That's the thing I didn't understand. I was like, where do we get? I understand like the.
No, that's right. 0.207. I've got that.
You did? Okay. Did you put 46.73 as the?
I put 46.733333. I put in a bunch of them.
And and they gave you that?
Mhm.
Gotcha. So we need to put more decimal points. All right. Awesome. I love this class. It makes me want to cry. All right. So we already know the p-value. Where are we at?
We're at compute the statistic. Oh no, we just did that, I think.
Yeah. What's the form? Okay, we did the formula.
Compute the p-value.
Huh?
All right. P-value.
Okay, that's when you go the probability applet, correct?
Yeah. What did you guys get? For P.
0.0836, is that correct? 0.0836. Oh no, it's 0.836.
Yeah.
So, and you're highlighting
The left and right side, because we're trying to find, that's what I need to understand. Do you guys, why do we need to shade? I know we need to shade the left and right when finding the p-value, but why? Does anybody know?
I don't know.
All right, I'm just writing questions down and then get some answers. See, this one like wasn't very hard, but it's a lot of, I feel like theoretical. I don't know. This lesson.
The notes I took, it says that when you're using the applet,
Mm-hmm.
if it's what is this one? Crap. If it's greater than, then you highlight the left side, and if it's, no, I think I'm saying it wrong. The one
Nope,
that's this
you're right.
way.
If it's greater than, then we're going to highlight the right side, correct? If it's less than, the left. And then if we need to find if it's a difference, if it's different, we need to do both. Which kind of
Right.
goes with the 1 and 2 side. Okay. It's kind of-
Right.
okay. It's all coming together.
Sorry. So greater than is the left.
Greater than will be the right side, correct?
Yeah,
Yeah.
yeah, and less than it would be the left side,
Yep.
and if it's just different, then it's both sides.
Gotcha. That makes complete sense. Okay.
And it was like when the zero, wait, no, I shouldn't say zero. When whatever we're measuring is greater than mu is the right.
Yeah.
Okay. Cool. Got it.
Oh.
Got it.
All right. What's number 10? Where are we at?
Compare
The p-value. We did
Yes.
graph your test. Okay. Compare the p-value to the level of significance, the A, which is 0.05. Right?
So we're gonna fail to reject. Let me find my.
We'll fail because it's much.
Because alpha is well, the p-value isn't less than the level of significance, which is alpha. So we can't, like, it doesn't change the null. The null hypothesis is gonna, like,
Because it's
go right.
less than. Is that what you're saying?
Yeah. If we were going to reject it, the
alpha
p-value
has to be lower.
Yeah.
Okay.
So.
Gotcha. All right. Number 10. State your conclusions in terms of the alternative hypothesis. The answer here says we have insufficient evidence to conclude that the mean age of people buying a second home is different in this area than that of the national average of 47.
Yep.
Which makes sense. I'm like, I feel like we had enough information when we knew the mean was 46.73, but whatever. Call me crazy. Anyway.
But they'll make it.
I really hope she doesn't watch this video. All right, I'm going to stop recording.
Okay.